Welcome to The Explainer. Today, we are diving into something pretty incredible, a brand new vehicle prototype called the Olinia Uno. We're going to use this ultra-affordable car as a lens to explore the real-world challenges of localized EV manufacturing, some deeply unique software engineering hurdles, and the rapidly shifting automotive regulations across North America. Okay, let's dive right into this. Can an electric vehicle really cost just $8,500? I know, you probably need to suspend your disbelief for a second. We are so used to EVs being these massive premium luxury products, right? Well, Mexico just unveiled a state-backed solution that is aiming to turn that assumption completely upside down. Because the exact target price of the Olinia Uno is 150,000 Mexican pesos. That translates to roughly 8,500 US dollars. Think about that. For the price of a couple of high-end MacBooks, you are getting a functioning car. And this isn't just some abstract concept or a sketch on a whiteboard. President Claudia Sheinbaum recently showed off a physical prototype of this car, and it is aimed specifically at providing affordable transit for the urban demographic. Here is our roadmap for today. Number 1, we'll meet the Olinia Uno. Number 2, engineering an urban EV. 3, the infrastructure challenge. 4, economics and Plan Mexico. And finally, number 5, the U.S. regulatory contrast. All right, section 1. Meet the Olinia Uno. Let's look at the physical prototype. Zooming in on the micro level first, the Olinia Uno is defined by severe, highly intentional technical constraints that are tailored for a very specific urban lifestyle. It actually features a 6-passenger capacity, and there's enough space to be wheelchair accessible. But listen to these performance caps. It has a top speed of just 50 kilometers per hour, which is about 31 miles per hour, and a maximum driving range of 125 kilometers or 77 miles. Because it has such a small battery architecture, it's designed to charge using a standard home power outlet. Literally, you just plug it in the same way you'd plug in your microwave. Section 2, engineering an urban EV. Let's talk about the massive shift in tech required to make this happen. Now, what's really interesting is when you contrast the Olinia Uno directly with long-range models currently sold in the Mexican market. Take a BYD Seal with all-wheel drive or a Tesla Model 3, those retail for around $51,000 or more. Those cars are engineered from the ground up for long-range capability, high-speed performance, and all those premium bells and whistles. The $8,500 Olinia Uno? It has a fundamentally different engineering target. It operates at the absolute floor of the EV market, prioritizing extreme cost reduction, strict urban efficiency, and localized assembly. For the software developers and engineers tuning in, these constraints force entirely different underlying architectures. The battery management system focuses on lithium iron phosphate chemistry, meaning it optimizes for the battery's lifespan or its state of health, rather than trying to squeeze in raw energy density. The software-defined vehicle architecture desperately needs hardware abstraction layers to manage heavily localized domestic controller networks. Even the ADAS, the Advanced Driver Assistance Systems, must be validated entirely around geofenced, low-speed pedestrian environments. And the charging APIs? They have to lean heavily on standard municipal plug-and-charge protocols like OCCP. Moving right along to Section 3, the infrastructure challenge, building the municipal ecosystem. Let's zoom out from the vehicle itself for a minute. To actually support the Olinia Uno's commercial launch in the summer of 2027, the Mexican government is pushing an incredibly aggressive plan to deploy up to 3,000 new charging stations. And the rollout strategy for this grid is highly sequential. Step 1 focuses on Mexico City, Step 2 expands out to the state of Mexico, and Step 3 moves into Puebla. You see, because a 125-kilometer range essentially eliminates cross-state commuting, the burden of energy replenishment completely shifts away from highway rest stops directly onto local municipal infrastructure. But here's the catch. This creates a massive grid integration challenge. Municipal charging networks are going to have to handle high-frequency, low-duration urban charging cycles. We are talking about rapid stop-and-go charging patterns all day long. Software developers building energy trading or grid balancing tools are going to be absolutely essential here. It's going to require centralized load management to prevent the local power grid from buckling during peak evening charging windows. Section 4, Economics and Plan Mexico. Taking a macroeconomic perspective, it is absolutely crucial to understand that the Olinia Uno isn't just a consumer vehicle, it's industrial policy. Right now, the prototype uses about a 50-50 split of domestic and imported materials. However, the Mexican government's stated goal is to push that domestic slice all the way up to 75% by the year 2030. They are determined to build a deeply localized supply chain for powertrains, battery packs, and vehicle electronics. This vehicle is practically the centerpiece of Plan Mexico, a 6-year strategy designed to elevate Mexico into the top 10 global economies. A major target of this whole initiative is achieving a 15% expansion of the country's participation in global auto supply chains. The real leverage here? Tariffs. Vehicles imported into Mexico from outside the USMCA region face steep duties, which makes locally assembled EVs a massive, direct economic lever. The government is essentially trying to trigger a demand-supply feedback loop. They're using state subsidies to fund the initial production ramp, expecting that volume manufacturing will eventually drop unit costs and normalize that $8,500 price tag without needing continuous intervention. Which brings us to Section 5, the U.S. regulatory contrast. Looking at the geopolitical layer. Now let's pivot and look at how the United States is approaching this space because it is a stark contrast. To really gauge this sentiment in the U.S. regarding affordable foreign EVs, just listen to this recent quote from Ford CEO Jim Farley regarding cheap Chinese vehicles. He said, "I sure hope we don't allow them to come across the border." That perfectly illustrates an intense protectionist sentiment in the U.S. right now. We've seen the implementation of 100% tariffs on Chinese EVs, the cancellation of federal EV subsidies, and lawmakers actively introducing legislation to ban connected cars built by adversarial countries from even entering the U.S. market. And this brilliantly illustrates the massive internal regulatory shift happening stateside. Based on the latest Federal Register documents regarding the NHTSA CAFE standards for model years 2022 to 2031, U.S. regulators are undeniably stepping back from forced EV adoption. These proposed rules eliminate EV mandate pressures. They end the credit trading systems that historically allowed internal combustion engine manufacturers to just buy compliance credits from EV makers. Instead, they are slowing fuel economy stringency increases to just 0.25% per year from 2027 to 2031 and leaning heavily back into traditional gas and hybrid compliance. And the stated goal of all this? To reduce average upfront vehicle costs for consumers by about $900. So the crucial takeaway here is this massive contrast. On one hand, we have Mexico pursuing a highly state-backed, localized urban EV strategy aimed right at that $8,500 price point, propped up by rapid municipal charging expansion. On the other hand, the United States is recalibrating its fuel standards to ease burdens on traditional gas and hybrid vehicles, removing EV mandates and deploying border tariffs to protect domestic manufacturing. We have two neighboring nations, deeply integrated by trade, adopting fundamentally opposite strategies for the future of auto manufacturing. Which leaves us with a pretty provocative question to chew on. Will hyper-localized, software-defined urban vehicles like the Olinia Uno drive the next major wave of global EV adoption, or will border tariffs and protectionist policies stifle this movement before it can even scale? It's an absolutely fascinating intersection of engineering, software, and geopolitics, and we will definitely be keeping a close eye on the Olinia Uno as it approaches that 2027 launch. Thanks so much for diving into the details with me today on this explainer. Catch you next time.